Welcome to this course titled Arduino-Based Robotics with an Introduction to Programming the Arduino Single Board Computer. My name is Brock Lemires and I will be your instructor for this fully online self-paced course. In this video we are going to go over the motivation for this course, the prerequisite knowledge needed to succeed, a short intro of myself as the voice in the videos, the required materials for the course, and finally how to navigate the course system. Okay, so let's begin with why we have this course. The purpose of this course is to provide an introduction to robotics as a platform to teach STEM. So STEM is science, technology, engineering, and math. And the whole purpose of this is that we want you to be able to go into your classrooms and feel comfortable creating your own hands-on learning modules based on robotics in order to teach them. We will be using the popular Arduino computer system as the brains for our robot, so we will also learn the basics of programming in Arduino. The intended audience is pre- and in-service teachers, and it's for people who wish to create hands-on activities using either robotics or programming the Arduino on its own. The Arduino is very versatile, so you can also apply some of the lessons to other types of experiments, but no robotic experience is required for this course. We will be walking through this as if you were a complete beginner. We will be programming in this course, so it is assumed that you have had some introductory exposure to the concepts of programming. So you should be familiar with basic constructs such as a sequence of tasks, decisions, and loops. And all the code in the course is provided for reference, so it provides a scaffold for learning. So you don't have to be a computer scientist to succeed in this course, but you should have at least been exposed to some sort of programming, whether it's graphical or text-based. Okay, so why are we going to use robotics? Robotics is a highly interdisciplinary platform that spans many different curriculums. Furthermore, the applications that robotics can be used for offer an endless supply of learning activities for classroom engagement. If you think about a robot and how it applies to STEM, there are numerous fields in engineering alone that are needed to design a robot. Mechanical engineering is needed to design the physical structure and moving parts. Electrical engineering is needed for the power system design and motor controllers. Computer engineering is needed for the computer hardware that runs the robot. Computer science is used to create the algorithms to control and operate the robot. Chemical engineering is needed to design the battery systems. And these are just a few of the engineering disciplines. There's many more that go into this. So robotics can be a way to introduce the profession of engineering. Another thing is it can be used to show the applications of science. For example, the Mars Curiosity rover that's shown in this picture, it was designed to accomplish 8 different scientific objectives on Mars. So these range from studying the geology to the atmosphere and climate science. So it wasn't necessarily exploration, it was a scientific mission. A robotic platform can be used to get students excited about science, oftentimes more so than using a traditional classroom experiment. Then another thing is, math. So if you go through STEM and you go through all the letters in this acronym, robotics can be used to stress the importance of math. Students can see how math was used to design the robot, in addition to how a computer system that's running the robot uses math to do things like measure distances and make decisions based on sensory input. So it's a good application to get them excited about math. And of course, a robot contains technology that spans numerous engineering disciplines and supports various scientific measurements. Also, it's in addition to being an all-inclusive platform for teaching STEM, robotics tend to excite students. Some of the robotic platforms that have been created by humanity are truly awe-inspiring. So often robotics can be the hook to get student engaged, and then they can apply the lessons of STEM behind that. Okay, one other thing that I always like to bring up is another often overlooked aspect of using robotics is that how it can show how STEM concepts are used to benefit society. Many robotic applications today involve helping people. These range from robotic surgery to performing hazardous tasks that would put humans in harm's way to prosthetics. And this shows that STEM is not just about working with technology, but it's about helping others to make the world a better place. This can go a long way to making STEM more appealing to students from underrepresented groups and help with strengthening the STEM workforce by increasing the number and diversity of the students choosing STEM careers. Okay, so since I'll be the voice in all of these videos, I thought I would take just a second and introduce myself. I am a professor of electrical and computer engineering at Montana State University in Bozeman, and I've been on the faculty here I'm starting my 12th year. I received my bachelor's in electrical engineering from MSU in 1998, and then I went to work for Hewlett-Packard in Colorado, where I designed electronic test equipment. In the 8 years I was at HP, I worked on my master's and PhD from the University of Colorado part-time, and then after that I returned to MSU as a professor. My technical area of expertise is in computer engineering, so I teach a wide range of hardware classes at MSU on computers and on robotics, and I also conduct research on computer technologies for space applications and how to improve student learning and motivation. My research is primarily sponsored by NASA and the National Science Foundation. I'm also the director of the Montana Engineering Education Research Center. Okay, so enough of background. Let's start talking about the details of this class. First of all of the programming and robotic activities are designed for a specific platform. It's designed for an Arduino-based robotic shield from a company called Parallax. You will need to purchase 2 items from Parallax in order to conduct the learning activities for this course. The first is called the Robotic Shield with Arduino. It's a kit that comes with an Arduino Uno and a shield called the Board of Education Shield. The shield, you'll hear about what a shield is, but a shield is basically a separate board that plugs onto the Arduino Uno and provides all the necessary circuitry to receive power from 5 AA batteries and drive electric motors. And the shield also has a prototyping area where we can experiment with building different circuits used by the robot. The Board of Education Shield acronym is BOE, and so a lot of times I call it the Bowie bot, so BOE bot, so Bowie bot. The second item that you'll need is a QTI line follower, and this is a kit of sensors that allows the Bowie bot to detect light and dark, and it's used to create a line following program, which is a very common application. If you have an Arduino Uno, you can actually go through their the Parallax website, and they do sell just the robotics kit without the Arduino for, I don't know, $20 less. But anyway, these are the things that the course was designed. This is the platform that we will be using. Okay. So at this point, what we want to do is I'm going to show you how to navigate through the course. So when you start, you're going to come to this welcome screen, and you'll see a picture of me sitting there with the Bowie bot, and there's one button to press. Okay, so you'll start off the course by clicking Start. And what it does is it goes to the first module, and at this point you'll be given an overview of the module, and you can use these forward and back buttons to navigate through the sections. Okay? A module is made up of one or more sections, and each module starts with an overview page like what we're looking at right here, and it indicates how many sections are in it. So this one has one section, okay? And we'll see other ones where there's actually more in it. Okay, I'll click the forward arrow, and we're going to be taken to the next slide in the course, and that's going to be this section overview slide. And this is the layout that you'll see on every one of these section overview slides. And what you see here is that over on the left there's 3 buttons. Okay, and there's going to be an intro button, and this is how you can always come back to just the description of what you're going to be doing. Then there's a video button, and if you click the video button, there'll be a video right here, and if you play it, it'll go full screen. And obviously you're watching a video, so you found that. And then you're going to have the activity button, and in the activity you will see you'll be given an explanation of what you're actually going to do for this. And so for this one right here, it's just a download of things, download a couple files. Okay, now before I click through some buttons and show you more of the course, let me show you another way to navigate the course. This button right here between the 2 arrow buttons is a menu button, and if I click this, it's going to bring a menu up, or slide out a menu on the left-hand side of this course. And what you can see here is this is another way to navigate through the course. So you'll notice that I can look at the modules, and I can see these little links to all the various sections. Okay. Another way to get to this menu is you can actually do this little expand collapse button right here. So it's always up in the upper left hand corner, so you can expand it and you can collapse it, and then if you expand it down here, you can collapse it by clicking that same button. So if I take a look at this, let's take a look at this menu a little bit, because I use this the most to navigate through the course. If I want to come down to Module 2, I can click on, the links are the ones nested underneath the module name. So if I click on Module 2, it's going to take me to the Module 2 section overview page, and you'll see that it's kind of like the same thing as Module 1. It had, picture me, and it's got 7 sections. So this module actually has 7 sections in it. Okay, so it's not just one. I can also see that if I look at the menu again, and I can go in here and I can scroll down, and I see that Module 2 has section 2.1, 2.2, 2.3, and so this menu allows you to kind of jump back and forth, so you can always access things that you want to see. So if you want to see material that was in the past, you can go over here. Another really neat thing of the menu is that these little check boxes, as you go through sections, what'll happen is it'll automatically populate these, so it gives you an indication of which of these screens that you have actually gone to. Okay, let's look at section 2.1. So I'm going to go to this first section and notice the similar layout. So now here we are again with the introduction to the section, the video for the section, and the activity for the section. Okay, and if I go arrow to the next section, same thing, intro, video, activity, and you just walk through these over and over and over. Okay, all right, so if I go back to the menu, one last thing to point out, this course actually has 8 modules in it. So if you scroll all the way to the bottom, you'll see that there's 8 modules. Okay, and as you go through them all, you'll get the little check boxes in here, and every one of them has a video, like a description, a video, and then an activity, and almost all the activities are some sort of robotic assembly and a programming exercise. Okay, and then when you complete the course, there's a certificate that you can print for yourself, and you just come in here, and let me close that, and you just type your name. So if I went in here and said, Brock, and I hit submit, it'll actually create a certificate, and then that shows you that you've completed. Okay, all honor system, of course. Okay. So here we are, and I can actually go back to the beginning, and for Module 1, that's almost it. But if you go into the learning activities, you're going to see some links, and one of into the activities spot, of course, the course overview, section 1.1. One of the things that you want to do is download the Parallax tutorial, and this is a tutorial that was built for the BowieBot, and it was created by Parallax, the company, and we're going to follow this closely. So this course was created to be kind of a subset of this very detailed tutorial. I mean, this tutorial's almost 200 pages, and we're not going to do all the activities in it, and we're going to have some activities that we do on our own, but we want to have this PDF readily available. So when you click on that first link in the course overview, go ahead and download that PDF. And then another one that you want to get is the allcode.pdf, and what you'll see is it's got all of the Arduino code that I walk through in all of the videos, so that you can reference it. So if you fall behind or something's just not working, all of the programs that I show you how to do are in this. And all of the activities that you do on your own, many of them are just duplicating what I've done. Many of them, and then there's some that you duplicate what I've done, but in a modified form. Okay, so everything's very scaffolded. You're not necessarily going to get turned loose to do stuff you don't know how to do. Everything is very put together, I guess. Okay, so you are ready to begin. Module 1 is essentially watching this video, which you are, and then going back to downloading the 2 PDFs, and you're ready to move on to Module 2. Okay, so that's it. I look forward to being your guide on this exciting journey to learning Arduino-based robotics.